What's up, all you mathematicians? Happy Monday. It is a great day to be a mathematician. Today, we're going to start your review on section two. Just to give you a little heads up, tomorrow I'll post the answers. And then, of course, Wednesday you're off. But you can still contact me if you need any help with things. And then Thursday will be our quiz. So, um, this section was all about compound inequalities. So we have two inequalities or such that we're going to solve. And then we're going to put our answers on our number line and then write our final inequality answer for most of them. So our first types of problems, we're dealing with sets of numbers. So I went ahead and wrote them down so you didn't have to watch me write them. So A is the set of numbers of x such that x is an even number. B is the set of x such that x are the odd numbers. So A is all the even numbers, B is all the odd numbers. C is the set 2, 3, 4, and 5, and D is the set 4, 5, 6, and 7. So your first set of problems will say, intersection or union. So our first one, we're going to do the intersection of A and D. So remember, intersection means things in both, right? So if A is all the even numbers and D is 4, 5, 6, and 7, what is in both A and D? Well, it would be the even numbers of D. So the intersection of A and D would be the even numbers 4 and 6. All right, and then for number 2, we'll do the union of B and C. So remember what union means. Union means put everything together. It's like an or statement, and intersection is like an and statement. So B is all of the odd numbers, and C is 2, 3, 4, and 5. So B is already going to cover the 3 and the 5 because it's all of the odd numbers, but additionally it's going to be 2 and 4. So how do you write that? B and C is the set, we're going to say 3 and 5, the odd numbers, and then we're also going to say x such that x is an odd number. So that covers everything in B and C. We've got 3 and 5. That's exclusive to C, and then all of the odd numbers, which is a mix of B and C because of the 3 and 5. Oh, shoot. Did I write that down wrong? Yeah, we already had the odd numbers covered, so it's not 3 and 5. Hopefully you caught that. It would be 2 and 4 plus all the odd numbers. Sorry about that. Okay, so there's some set things, union and intersection. Remember, union looks like a U. Intersection, there's a letter N in intersection. It starts with kind of, you say the word N. So that's how I remember them. Okay, let's look at some actual compound inequality ones. So the first one's going to be nice and easy. They're already going to be solved for us. X is greater or less than or equal to negative 3, and x is greater than negative 2. Okay, so let's say you've already solved some problems. This is the solutions you got. So remember how you want to do this. You're going to put both of your numbers on the number line. So negative 3 would be to the left of negative 2 on a number line. I should have done a different color. So let's say the pink represents my first one. That would be a closed circle on negative 3 and shaded to the left. And let's say I wrote this one in green because I like to do different colors, makes it easier. So let's say my green solution, so you'd have still negative 3 and negative 2, would be a closed circle shaded to the right. So and means where is it true for both? So we look, it's only true for negative 3 and to the left on 1, and it's not true for either here, and it's only true for 1 there. So there's nowhere that it overlaps. You have to have an overlapping for and. So this is actually a no solution. There's nowhere where x is less than negative 3 and also at the same time bigger than negative 2. And on a number line, that would just be an empty number line, nothing shaded on that number line. Okay, let's do another one. number 4 here. All right, we'll actually solve some of this one. 4x plus 2 is less than or equal to negative 10, and 2x is less than or equal to 0. Okay, so you go about solving both of these. So this one, you'd start by subtracting negative 2, and 4x would be less than or equal to negative 12. You would divide by 4, and x is less than or equal to negative 3. All right, that one's solved. Second one just takes one step to get x by itself. You would divide both sides by 2, and x would be less than or equal to 0. Okay, so let's graph both of our solutions. So on a number line, negative 3 would be to the left of 0. My first solution would be a closed circle on negative 3 and shaded to the left. My green solution, still have negative 3 and 0 on it. It would be a closed circle on 0 and shaded to the left. So it's an and, so where is it true for both? Where does it overlap? It overlaps right here. So our final answer, our final number line, we're going to take that overlapping and put it together. It would be a closed circle because we had a closed circle and shaded to the left. And then what is that final inequality? What does this number line represent? That shows that x is less than or equal to negative 3. So that's my final solution there. Okay, the next type of problem that you'll see are those compound inequalities where they're kind of just one big string of things. So let's look at that. Negative 5 is less than negative 3x plus 1 all over 4, which is less than or equal to 2. Okay, so remember on these, whatever you do to the middle to get x by itself, you have to do to both sides. So the first thing you'd want to get rid of is that 4. Since that 4 is dividing, the opposite would be to multiply everything by 4. So you do 4 times negative 5 and get negative 20. The 4's would cancel each other out in the middle, so you'd just be left with the negative 3x plus 1. And then 4 times 2 is 8. What's the next thing you would get rid of to get x by itself? You would get rid of that 1 by subtracting 1 from all sides. So it looks like we would have negative 21 is less than negative 3x is less than or equal to 7. Last thing you'd do is get rid of that negative 3 by dividing by negative 3. Those in the middle cancel. A negative and a negative make a positive. 21 divided by 3 is 7 is less than x. This one doesn't reduce, and then we just like the negative to be in the top, so we're going to float it up to the top and call it negative 7 over 3. Okay, so remember with compound inequalities, you don't have to, or like this string of ones together, you don't have to make two number lines and then put them together, because you know what these will always look like in the end. In the end, that's weird. Oh shoot, you know what I did? I kind of did make a mistake. I forgot. I divided there by a negative. What happens when I divide by a negative? My signs need to flip, which means that this isn't quite ready to graph because our final one needs to be in less than symbols and from smallest to biggest. So we need to flip that around and call it negative 7/3 is less than or equal to x is less than 7. Okay, so now we can put negative 7/3 there and positive 7 on the right, just like the order it is in. I noticed I made a mistake when my final answer wasn't from smallest to biggest. It went from biggest to smallest. So I knew I had to flip it around. So let's look. It would be a closed circle on negative 7/3. It would be an open circle on 7. And these are always shaded in between. So when you have a problem like this, it's always shaded in between. Okay, we've got 3 more examples for you. Number 6, we're going to do some ors now. X is less than 4 or x is less than 5. So again, we've already solved some things. We're going to put both of our solutions on a number line. So on a number line, 4 would be to the left of 5. So that would be an open circle on 4 shaded to the left there. It would be an open circle on 5 shaded to the left on that one as well. So for an or statement, it just has to be true for at least one of them. So it would be it's here and here where it's true for at least one of them. It's not true for either of them over here. So if you put them together, where is it true for at least one? It would be that open circle on 5 and then shaded to the left when you put them together. Let's look at another one like that. X is less than or equal to -4, or X is greater than or equal to 1. Oh, you know what? I'm sorry. I forgot to write my final inequality on 6. So how do you write that? What does this number line represent? It represents X is less than 5. So that would be our final answer. X is less than 5, and that's our number line. That's what it would look like. On this one, I wanted to put this one because it's a little bit different. -4 on the left, 1 on the right. -4 on the left, 1 on the right. Okay, that would be a closed circle on -4, shaded to the left. That would be a closed circle on 1, shaded to the right. Where is it true for at least one of them? Well, it's true for at least one of them here and there, not in the middle. So our final number line would be a closed circle on 1 and a closed circle on 4, shaded to the outside. So how do you write that as an inequality? Well, it doesn't change because it says both of these things and nothing overlapped. So our final inequality, we would just rewrite X is less than or equal to -4, or X is greater than or equal to 1. Okay, one more. I don't know if I have enough room, so I'm going to come over here to the side of these problems. I hope you don't mind. Number 8. Okay. Last one, we've got 3 times x minus 1 is greater than or equal to -5, or x plus 7 is greater than 10. Okay, let's solve that one on the left first. How would you start? By distributing, right? 3x minus 3 greater than or equal to -5. Next, you would add 3. 3x is greater than or equal to -2. Last, you would divide by 3. I did not divide by a negative number, so I do not need to flip my inequality. That fraction doesn't reduce, so it would stay greater than or equal to -2/3. My second one just takes one step. We would subtract 7 from both sides. Sorry, that's a little sloppy. I should have went below the hole, but that's okay. X is greater than 10 minus 7, 3. Okay, let's graph that one first since I've got my green pen with me. So on a number line, -2/3 would be to the left of 3. That would be an open circle on 3, and you would shade that one to the right. And then my red solution there, -2/3 and 3. That would be a closed circle on -2/3 and shaded to the right. So where do those have at least one true? In the middle and to the right. So for my final inequality, that would be the closed circle because that's what I had before, shaded to the right because that's where it's true for at least one of them. And then what does that number line represent as an inequality? X is greater than or equal to -2/3. That's what that one is showing. So that would be our final solution. We can collapse these into just that one inequality. So let me know if you need any help with any of these problems as you're working through. By the way, on the review sheet, you're going to be doing problems 4 through 72, the multiples of 4. So 4, 8, 12, 16, 20, and so on. Let me know if you need any help with anything. Again, I'll post the answers tomorrow, and you can ask any questions you need to. You remember your quiz will be Thursday, since Wednesday there is no math class. Have a great day. We'll talk to you later.